All right. Welcome to all those that probably aren't there. Um, so today, what we were supposed to be working on here was Mod the Cube. Had a little bit of a delay in getting back to this because I got distracted with a side project, and unfortunately, that side project is still going to distract me. I mean, unfortunately. But that's what we're going to be working on today. For one reason, pretty much, is I don't want to have two instances of Unity open because my poor computer, and I can't save the changes that I made so far to this project. So, we're going to keep working on this side project. And the funny thing is, the lessons from what I need to do here and what we were supposed to be working on in Mod the Cube, pretty similar. Currently, we're trying to figure out translating our player, which is this little triangle, and moving him around the map using rotations. And we're also going to try to figure out collision. This is what was stumping us on our side project. I say us, I was working on this with a friend. So, just going to take the time to work on this today. So, if you're interested in my Instagram at all, I made these tile maps yesterday. I made 6 of them. They're okay, but it was a fun thing to learn. Did some pixel art, learned how to slice them up in Unity and put them into a auto tiler so that it'll do the mapping and the borders for me based on the tiles that I created. If we want, we can just look at those real quick. It might be a little easier just to take a look at all of them as the pictures. Yeah, so I made all of these tile maps. Even if they suck, I still have to be a little bit proud. I did discover one thing that was really annoying is there's one bar of missing pixels on one of the slices. So that was really annoying. I had to go back and fix the individual tile maps by exporting a PNG of just that slice and putting it in here. But if anybody's interested in more details on that, I'll be glad to talk about it. So currently what we've got set up is our board here with our player character. We've got some tiles that are supposed to be a border. He wanted to set up collision through physics, but because it's a tile map, I kind of think that that's not needed, and it can probably be done through code. So let's go ahead. Player move point. I see. I want to hide this for right now because it looks stupid. And yeah, I see he's got a rigid body on here. So for right now, let's just leave this alone, but let's go ahead and try to get into code. Scripts. Grid movement. I think this is what he was working on, so let's take a look. Alright, let's see. So we've got a boolean for is moving. Actually, first before we do this, let's see what's happening when we hit play. Variable tile map of grid movement has not been assigned. Well, so then right now it does nothing. Let's see. Yeah, that makes sense. The code isn't even attached to the player. Well, just for giggles then, let's see what happens if we put it on here. Yeah, we probably want to put it on the... Man, am I stupid or what? It's right there. Oh, tile map. We need to attach a tile map. Okay, now let's see. Okay, so it's saying that all the spaces are occupied. It's telling me that in the little console line down here, so it's not letting me move. Question is why? The tile is occupied. Okay, let's take a look at this. Where is it telling us that it's occupied? So we've got a world position. We've got the tile map reference. Time to move, so this is kind of a speed and the tile size. If the arrow keys are pressed, it should move the player in that direction. Original position equals transform position. Interesting. Oh, I see. So it's an enumerator for when they're moving, it's going to set it to true so that you can't put any more inputs in. Target position equals new. Transform position X. Tile size times tile size. Direction times tile size. Interesting. Check if the target... Okay, here's what we're looking for. Check if the target position is occupied by a tile. The tile at target position is occupied. This is what we were seeing. The target position is not occupied. So you need to... Well, this looks like it's just for reporting. But it also wasn't moving when we were trying it, so let's see. Move the player towards the target position. While elapsed time is less than time to move, transform the position. Lerp. Linearly interpolates between 2 points. Okay. From the original position to the target position of the elapsed time divided by the time to move. Elapsed time adds time equal to time plus delta, or time dot delta time. Yield return null. Snapped to the target position after the movement completes. Transform position equals target position is moving equals false, so it sets it to false again. And this is all... Well, this is update, but oh, I see, start coroutine. So, is tile occupied? If a tile is found at this position, it's occupied. Tile base tile equals tile map dot get tile group position. So I think the goal here then is, because we want the tiles to also be a background as well as a border, the intention should be a collidable tile and a non-collidable tile. Non-collidable tile being these borders, whereas the collidable tile is more like a background. We could probably do this 2 ways. One, remove the background portion from the tile map so that it just displays as a background, and then use the script movement to prevent movement to the border tile map, which is specified. Let's give that a try then. So we'll do this. We'll do another tile map. This one's going to be called background. And this one's going to be called border. And then here's what I'm going to do. I want to change my prefab by turning this into the prefab. And I want to call this base map. Actually, I should do this in a second, because the first thing that I want to do is, in this, use my tile palette to erase all these tiles. Can I do fill with erase? No. Okay, so this is going to be the border then. And now, background, or open a different tile palette just in case it's different. I'm going to use the same auto tiler that I made here, except for using horizontal. I'm going to very simply draw a square, fill it, done. So now what I want is to make this into a prefab called base map. And for consistency, I'm going to name this one base map as well. So the base map has two parts, the border and the background. What we need is, in the script for grid movement, where it references a tile map, we need to put in the border tile map. Okay. Grid movement, border, background. Oops. Does it just want this? What does it want? Okay, what if we make a new tile map? Will it see that one? Tile map called test. Movement, tile map. It still sees nothing. Is this because I have to do the... There we go. So, with the player using the border tile map, let's try it again. Minus 0.5. Oh, okay. Okay. Let's adjust this then. So, let's set the entirety of the base map to minus 0.01. No, not 0.01. Let's just do minus 0.1. This should set all the components there. Because what was happening was when I was moving the player object, it looked like it was setting the Z to 0. Yeah, because currently it's set to minus 0.5, but when I moved it, it was set to 0. Oops. And now it sets itself to... No, that's base map. Interesting. I can see it moving around. The Z is weird. Oh, wait. If the Z is set to 0, what's the camera at? Minus 1, it should be able to see it. Okay. So let's try this. What's it look like in 3D? Where's our player? it's just behind the tile map here. So if we take base map, which is at -0.1, and we just say fine, go to minus. Oh, -1 is moving it away. We'll go to 1. Or better yet, 0.1. Does this help? It does. Okay. So let's make sure we get these changes in here. Base map should be +0.1. While the camera and the player are fine. Now, when we go to move, what we get is a sliding object. So what's not working is the snapping. And the collision is working, but it's far off. And it doesn't work on the bottom side. Does it work on the left side? Okay, no, so then I think it's shifted, basically. Yeah, if that's supposed to be the upper corner, let's see how it's first back to 2D. The camera's fine where it is. The border is still listed that way. Tile anchor. I don't think it has anything to do with the layers. Maybe it's just the code. Let's see. Get the tile at given grid position. Maybe it's an offset? I see offset is grayed out. I don't know that that would make much of a difference. What if we can do this a different way? What if instead of having it detect if a tile is there, we can tell it where the tiles that it can't touch are? But how do you do that? Let's see. Unity tile map collisions. Adding collisions for your tile maps and 2D characters. Sounds useful. Oh, you know what? So let's do this. I'm just gonna pause the music real quick. I watched this guy.
Here's how you can add an
tile map. let's go ahead and check this out.
Automatic dynamic tile map collider that connects in under a minute. Firstly, I have my tile map here with no collision at all. We're going to add a tile map collider component, and you can see the individual boxes on each tile map. We want to combine them, so we're going to add a composite collider 2D, which will help merge them. In turn, this will automatically add a rigid body 2D. We need to set the body type to kinematic, the collision detection to continuous, and the interpolate mode to interpolate. Let's also freeze the position and rotation. Finally, on our tile map collider, let's check used by composite to combine the colliders into one dynamic collider. Subscribe for more.
Okay, well, what he said kind of makes some sense here. Let me drag this off to the side. Let's take a look at it in Unity here just to see what we've got. So border is set without any collisions. Oh, that's right. I said that I wanted to do this through code, not through physics. So let's adjust the Google search. Man, I really spelled everything wrong here. Unity tile map collision through code. Okay, so the automated response here says to create it through code, you need to add, so it still needs the Collider 2D component. You can use the process tile map changes method to update the collider after making changes to the tile map. The component is added to the tile map game object to create individual colliders for each tile. The composite turns them all into one collider. Requires rigid body. It should be set to static for platforms and dynamic for the player. Controls how much the tile collider shapes are extruded to prevent gaps between the tiles using a composite collider. Let's see here. Oh, well, this is just serialized build product. Okay. The shape of the collider for each tile is determined by the physics shape assigned to the tile sprite. If you don't have a physics shape defined, you might need to create one using the sprite editor or set sprite outline generation. Is that what's messed up? Let's check individual. So chunk. Let's check that out. Unity tile map renderer mode. And in my classic fashion, I misspelled a bunch of words. Chunk mode is the default rendering mode of the tile map renderer. When set to chunk mode, the tile map renderer handles sprites on a tile map in batches and renders them together. They are treated as a single sort item when sorted in the 2D transparent cube. Yeah, let's read up on this. Throw this over here so it can be read. Okay, nothing to read. Good job. There we go. So, when set to chunk mode, the tile map renderer handles sprites on a tile map in batches, right? This is the part that I read. This reduces the number of draw cells to improve overall performance. However, other renderers cannot be rendered in between any portion of the tile map, which prevents other rendered sprites from being able to interweave with the tile map sprites. Okay. I really wanted to see individual mode. Oh, that's cute. Using this mode, if other renderers interact with the sprites and objects on the tile map. In this mode, the tile map renderer sorts sprites based on their position on the tile map, and the sorting property is set in the tile map renderer. For example, this allows a character sprite to go in between obstacle sprites. I see. So I don't think it's going to be this individual mode. All right. In that case, let's just check out one of these videos here.
It's easy to find tutorials about tile maps, and also about 2D characters. But then you sit there with your map and your player, and this is where the tricky part starts. Why is my collision not working? Why is my player in front of the map? Why is my player behind the map? Can I please throw this away? But it's all fine. Let's just try to calm down and solve this like a pro. Following all my tutorials, you now have 2 tile maps. One for the background and one on top with activated collisions.
Oh, okay. Good to know that that method that we used wasn't just some ghetto workaround. It's an actual thing.
In my case, this looks like this. I don't want the player to walk into the water, so I simply put it onto the other tile map.
So she does do it this way where she has 2 tile maps, one where they're supposed to collide and one where they're supposed to be a background. Yeah, that's really good to know. Let's see how she has them interact.
Of course, feel free to create as many separate maps as you want. We then added this 2D character of this half-naked dude, made him walk, and animated this. This looks good until I let him randomly walk through my map and he suddenly is Jesus. In my Tile Maps Basics video, I explained how to use colliders with tile maps, but never how this applies to the player and how they interact with one another. So let's start with this topic, and then we will take a look into layering all our objects in the next episode. As this video is player oriented, not tile map oriented, I recommend you to take a look at my tile maps video. But based on its current view count, it's most likely you already saw this. And this is good, so thank you for this. Otherwise, please take a look at the collider part. You should then end up with at least one tile map that has some colliders on it. A tile map collider 2D, which is used by a composite collider 2D. You can see the collider lines here in the scene window, marked by this light green line. For every collision, both colliding objects need a collider. Currently, our player doesn't have one, so it's obvious why he can't just walk through my map. So let's add one. You can use any 2D collider you want, but in this case a box collider 2D fits the best. For jump and run games you might want to take a look into edge colliders, but this is not relevant here. Let me just get rid of this input icon here, so now we can see the collision lines, and adjust it to our needs. And with a polygon collider you can even create more customized shapes. My collider will only be located at the feet of the player. When starting the game, your collision should work. Due to the collision being only at the feet, you also get a feeling of the player being much more involved in the world, and it looks like he really stands in front of this bin. But one important thing to keep in mind, collisions are a physics thing in Unity, so one of the 2 colliding objects need a rigid body attached to it. In our case, the tile map as well as the player have one, so this works out of the box. Physics are also a funny thing in Unity. Of course, we don't want the player to spin like this. Exactly, he must not spin or rotate in any way. Leave play mode and in the rigid body settings, open this Constraints tab.
Freeze,
Here you can restrict any axis for movement and rotation. We want to move on the X and Y axis, so that's fine. But let's constrain any force applied to the rotation axis. When now walking around collision corners, nothing happens. When walking diagonally against the collision edge, you can see the player moves slower. This is because there is a little friction between both colliders. If you don't want this, you need to create your own physics material for the rigid body. Let's create a new folder called Physics.
Okay. I think a little different than what I'm trying to do. Let's put a pin in this because I think this is a helpful video, but want to see if there's others. On the other hand, it seems like doing this through code is so unpopular that it might not be necessary. So, um, let's run this back. Uh, so we still got movement in here. Let's do this. Ah, let's just comment that out. So the other thing that we really don't need is tile occupied. Um, and in case you're curious, that keybind is control slash, so that instead of clicking on everyone and typing the slashes, everything that's highlighted becomes commented out. And I'm just gonna copy this line and put it here. Whoa, didn't want it to tab it. Still didn't want it to tab it. All right, whatever. Okay, so that should take care of that. So with this case, save. Let's see what happens with movement now. Spin. Oh, were we commenting on the YouTube video with the character spinning around? Sorry, I missed that chat. Okay, let's see what happens now. Okay, so now it doesn't collide, which means that I successfully removed it from the code. Now let's do the physics. So she said two. Yeah, let me look at it. Let's pull that part up. Rigid body and tile map collider. So yeah, there's our tile map. Okay. No physics material. It's not a trigger. Okay, so with this having a collider, let's make sure our... Do we want just the sprite to have the collider? Probably not, right? Let me just move this to the total player. Of course I did that and I forgot what I just removed from there. Can I undo? Rigid body. Gosh. Okay, so now let's add this back. Rigid body 2D. So I saw on another one that it said you want to use kinematic. I don't know what that is. So, dude, I'm with you. That's exactly what I'm trying to do here. Is I'm trying to learn everything. I explained earlier when I had 0 viewers because you have to talk to the air when you have no viewers. Um, I was trying to work on the learning pathways. This one from Mod the Cube. This is pretty early on. Um, and in case you didn't know about these learning pathways, this is a great way to have some Unity made tutorials for teaching you the Unity platform. Um, but I was working on this earlier, and this was trying to teach just about simple stuff like transforming your pieces. If you're interested, you can learn these yourself. But this is just what I'm trying to walk through on stream is learning these pathways with Unity. Today is a little more learn by doing though, instead of having it explained, minus the YouTube videos, I guess. Um, Gotta lock in because I forgot what I was doing. Right, I was going to check out. No, that's fair. I kind of liked Unity just because one, it's free, two, it has a large knowledge base, and it seems like a lot of other people use it, so it's kind of easy to learn that way. But I've also seen some other simple platforms like Godot or Godot or however you say it. So let's check out. Let me do this so I can see what I'm trying to look up. These body types. So let's see. Unity, rigid, body, 2D, body types. What are these? Three body type options. Affects the movement behavior with the position and the rotation and collider interactions. Game Maker. I think I've heard of that one. I see. So do you just like to make 2D games? Because, I mean, I guess that's part of the other reason that I wanted to use Unity is I don't want to just do 2D. But, gotta start simple. That's fair. Okay, when a body type changes, Unity recalculates various mass-related internal properties and all existing contacts for the collider's 2D attached to the rigid 2D. Needs to be reevaluated using a fixed update. Okay, it's a little bit of nonsense, but sure. Depending on how many contacts and colliders are attached to the body, changing the body type can cause variations in performance. Okay. The properties. Oh, it just took me to a page with a bunch of other pages linked. That's fine. Oh, cool. Pre-rendered 3D. I see. I see. Okay. Yeah, that's cool. Understand the dynamic body type. That's what it's defaulted to. So let's see. It's a body type for the rigid 2D. Most common body type for things that need to move and is designed to move under simulation. Okay. Render the models into Blender. Render the models in Blender into frames and then use the frames as 2D sprites. That's kind of cool. Like you're like slicing it up. Yeah, that's the other thing that I gotta learn is Blender, because I gotta do some modeling for myself. I can't just run off free stuff for forever. A dynamic body. Thanks, man. I appreciate it. Yeah, if you're ever interested in Unity or you want to try to pick up a tip or two, or if I'm just that entertaining, come come hit me up. Um, just for the record, I'm streaming in the daytime now because I'm off for a little while, but I'm intending to stream later in the night, like 9 p.m. or so, once I'm not off from work. Thanks, bro. We're all chill around here. If you're interested, I've got other attached social media, I guess, like Discord and other stuff attached on my stream. If you want to check out those too, that'd be cool. Also, the Discord, we could just chat. The most exporm. Wow, I messed that up. Performance expensive body type. Okay, so let's see what kinematic is because that was the one that I heard. 6 a.m. for you, bro. Where are you? What am I even trying to look up? Time zones. Russia. Yeah, I should have just waited for an answer. That's crazy. It's almost 12 hours apart. Is that 9? 9 hours? I think so. No, I'm straight up crazy. I don't know. Whatever. We're here for games, not math. Unless. Right. Okay, designed to move under simulation, under very explicit user control. I see. This already sounds more appropriate. Oh, you're just chilling late at night, huh? Ooh. Kinematic bodies are not affected by gravity and forces. That is useful here. Lower demand on system resource usage. That's good too. They must be repositioned explicitly via. Oh, oh, going to college. Yeah, cool. Are you studying game design or is this just a hobby of yours? Okay. Use physics queries to detect collisions and scripts to decide where and how the rigid body should move. This is perfect. It's just a hobby. Yeah, no, I feel you there. I like, I think it's smart to have a hobby that keeps you learning. And if you're really good at it, you could potentially make a little bit of dough. Yeah, because this is just a hobby for me too. I just kind of tried to blow it up into a stream and see what I could learn out of it. So right off the bat, I'm just going to go ahead and set this to kinematic. But let's still read what static is. Static is designed to not move under simulation at all. If anything collides with it, static behaves like an immovable object. Dude, this is perfect for the border then. It's the least resource intensive body type. A static body only collides with dynamic rigid 2D bodies. Sweet, man. Here, I'll, before I forget. Welcome, it's just you and me. Roles, Twitch, user. All right, let's see here. So, purple for Twitch. This is the only thing that concerns me. A static body only collides with dynamic rigid bodies. Not kinematic? Or is kinematic a type of dynamic? Let me... Maybe this will help. Yeah, because now I'm actually interested in the physics.
But one important thing to keep in mind. Collisions are a physics thing in Unity. So one of the two colliding objects need a rigid body attached to it.
Right.
In our case, the tile map as well as the player have one. So this works out of the box. Physics are also a funny thing in Unity.
Oh, this
Of
is the
course, we
spinning.
don't want the player to spin like this. Exactly, he must not spin or rotate in any way. Leave play mode and in the rigid body setting.
Yeah, that's what it's for. If you want to share, actually, let me join you. This is here's a tile map that I made the other day. There we go. Yeah, feel free to share in there. If you can't, or if it gives you any trouble, let me know, because I'm not sure on the permissions. I didn't really test everything.
Open this Constraints tab. Here you can restrict any axis for movement and rotation. We want to move on the X and Y axis, so that's fine. But let's constrain any force applied to.
Do we need to restrict rotation? That's not doing anything. That's also not doing anything. Am I crazy? Is it because it's in 2D? Oh, no, it just was really, really slight. 90. So if we're back in 2D and this goes to 90, yeah, it's invisible. So we don't want that. Where did that go? Okay, so in that case, it sounds like we're... What about small game devs and silly recordings? Can share in the same channel. What you mean? Like short recorded videos that you've got? Actually. Uh, Good question. I would say if it's I would say if it's an educational video, like if you're trying to give a little tutorial, throw it in the learning channel. Um, Otherwise, if you're just goofing around, like if you just made some goofy animation, you could probably just put it in general. If it lets you, it might not. Let me know. I guess you're my guinea pig. Schematic. Collision detection. You know what? While we're here, let's just check out what all these are, because some of this is probably useful. Rigid can still move by its velocity, but the velocity is not affected by forces or gravity. I see. Oh, it only collides with dynamic rigid tubes. Well, what do? Kinematics seems so useful, but okay, more research required there. There's a scenario where a static rigid body is created. This is where a game object with a collider 2D component does not have a rigid body component at all. All collider 2Ds without a rigid body component are internally considered to be attached to a single hidden static rigid body. Okay, so it's kind of like the default. If it's not given a collider 2D, then by default it gives a static rigid 2D. Rigid body. This means that you are able to create a large number of static collider 2Ds, as you do not have to add a rigid body component to them. Both methods of creating static have their advantages depending on the scenario. If an individual needs to be moved or reconfigured at runtime, then add a rigid body. Oh, I see. So basically, if it's going to be completely stationary, then it probably doesn't even need a collider object. Well, that makes sense, because then that's just like obstacles. Busy yapping. Forgot to turn the music back on. Oops. So, since we have a fair understanding now of these body types, let's go ahead and just leave this on kinematic. See if this changes anything. Yeah, man. See you around. It's nice to have you. Thanks for popping in, chatting. Okay, so it won't move diagonally now. That's interesting. It only moves in the cardinal directions. That's kind of intended. That is one of the goals here. Here's the question, is how to convert pixels to coordinates. Because I know that these boxes are 64 pixels big. That's how big the unit is on the grid as well. So technically I would only need to move the triangle 64 pixels. But what does that look like? Is it just one unit? Oh, dude, man, I'm stupid. Yeah, because it's 1 to 64. So, we take minus 8.74 to minus 9.74. It puts it in the right spot, but let's do 7, 6, 5, 4, 3, 2, 1. Check the grid. It's still within the grid. It's still in its same position. So then, the destination is get out of here. Nobody wants your fake bot actions. Okay. So then I think in the script, instead what we can focus on is I don't know. Transform position. You know what? I want to understand that interpolation too before I do this. Unity. Rigid body 2D. Interpolate. Interpolation is used to estimate the position of the rigid body between physics updates. It can be useful to switch this on when the graphics update is much more frequent than the physics update because the object can appear to move along in jerky hops rather than having a smooth motion. With interpolate mode, motion is smoothed based on the object's position in previous frames. Extrapolate mode smooths motion based on an estimate of the position in the next frame. The choice of mode depends on the dynamics of the object during the gameplay. Well, let's see. Let's see if interpolate, extrapolate I get that it's past versus future, but what does it look like? How about this?
To the rotation axis.
Oops.
Do you really want to spend the rest of your life watching ads?
No, I
Guys,
don't.
just download Pi. It's a free Google Chrome extension and it
So like I said in the previous video, interpolate smoothens the position between the previous frame and the current frame in fixed time step, and extrapolate smoothens the position between the current frame and it tries to predict the position of the object in the next frame in the fixed time step. So if I go to edit, project settings, time, you will notice that the fixed time step is set to 0.02. If I change this value to 0.3, now rigid body will update the position of the cube only after 0.3 seconds. So I'm going to hit on the play button now. You will notice that the cube is falling with a judder and it's clearly visible. This is because Unity is updating the position of this object only after 0.3 seconds. Now I will turn on interpolate. And now I'm going to hit on the play button. You will notice that the object is falling very smoothly right now. This is because interpolate is actually smoothing the positions between the previous frame and the current frame. Now I'm going to turn on extrapolate and hit on the play button. You will notice that the cube is still pretty smoothly falling on the ground. But in the end, you will notice that the cube went in the ground a bit and then came back. This is because extrapolate was trying to predict the position of the cube into the future and it didn't know about the ground.
Yeah.
So once the collision occurred, it put the cube back to the position where it should be.
Well, then that kind of raises the question, when is extrapolate better than interpolate? Actually, that was a good
So
video.
like I said,
let me give this one a like. When to use extrapolate. Extrapolate is usually only a good option for situations where accuracy is not important. For example, the rigid body moves at a constant velocity and there are no other physics elements that influence the rigid body's movement. So probably, I guess something like an infinite scroller or something where you're always moving and you technically don't get hit by anything. But then when you do, like say the Dino game from Google Chrome, then when you do finally get hit or something, it's like it doesn't matter because game's over. Okay, I can buy that. Let's pop open. I don't think this is even necessary then. Should kinematic static collisions be allowed? Oh, you can just choose to set it. Well, then yes. That's wonderful. So then I can come over here to the tile map collider. Let me give this a rigid body 2D as well, and let's make this one static. So, does this work? Oh, it kind of did for like half a second, but I don't think it did it right. No, no, no. I think it needs a collider still, actually. So player has the rigid body. Let's give it the collision. Yeah, you know what? Let's just do... You know what? I don't think box colliders. What about custom collider? No. Let's remove this. I need to use the restroom, so I will be right back. Alright, back to it. Short and sweet break. So. For constraints, since this is a 2D game, we definitely don't want X and Y rotating. We do only want Z to rotate. So, since that's on here, that'll work. Let's go ahead and leave it that way. For interpolate, I really don't think this is necessary. I want smooth motion, but I think that it can be done without this. I just will keep that in mind. I think that's all that's necessary from the rigid body. So, I think what I want to do here is I want to try to make my own script just so that I don't interrupt this. So with that, I'm going to go ahead and uncomment these items that I messed with before. I'm just going to leave this. I don't want to save any changes here. Let me make a new script. Create model behavior script. We'll call this player movement. Let's open this up. So let's start simple. What do we need to do? First things first, we need to translate the object from point A to point B. The distance of that should only be 1 because it's on a grid. So let's see. We need to do this whenever the keys are pressed. So we're trying to move with arrow keys. So whenever one of those arrow keys is pressed, it should move in the respective direction. So down, move down. Let's do if get key down. No, what is this? Input dot get key down. Isn't there a difference between get key and get key down? Because I want it to be like when it's pushed, but not do it when it's held. I want it to only move once. Get key. Okay, fine, fuckhead. Get key remains true while the user holds the key identified. Remains true during the frame the user starts pressing the down key. Alright, whatever. Input.getKeyDown equals... No? Get Dang it, I forgot how to do this. This is like literally one of the most basic things too. So let's just in Unity input dot get key down. So let's see. Returns true during the frame that the user starts pressing the down key identified by name. Oh, I see. If input.getKeyDown. Okay. So it should be as simple as that. Let's go ahead and run that again. If input.getKeyDown, down? No. Let's see how does it see it. I remember there's a way to see this, but Okay. Okay, you know what? Better yet, let's just... Not that one. That's the one. E-code, that's what it is. Jeez. Okay. And these are the items that it can have. So. Key code dot down arrow. If this happens, we'll put a pin in that because we need to duplicate this a couple times. Key code up arrow. Key code left arrow. And key code right arrow. This should be simple. We need to get it from a starting position to an ending position. During that position change, it needs to rotate 90 degrees. And it needs to do it smoothly. So I think whenever one of those is pressed, it's going to need to run a function one that's responsible for moving it, one that's responsible for rotating it, and those are going to have to be over time. So I think we don't want it in start and we don't want it in update. I don't think there's anything that necessarily needs to be done at start. We could make it so that the player snaps to a starting position, and that starting position is like an invisible tile that isn't seen in the game view, but it's like a method of level design, I guess, because there still has to be a start and there has to be a goal. But we'll get back to that. Let's see. So we've got our inputs signified there. Well, I'm brain dead. Let's try this. Since we know we're translating and we know we're rotating, let's just do this. we want to set up rotation in degrees. We know it's only the Z that needs to be rotated. Let's set up some variables. Rotations. Whoa. Oh, that's right. Public float rotation speed. Public float translation speed. No, we don't need a multiplier or anything like that. These should be pretty static. So think. What needs to be done? Start small, start small. Let's focus on moving, translating. We need to translate the object from one tile to another. This should be done simply by taking its starting position, adding 1 to it to get to its destination, dependent on the direction that it's moving. So since it's dependent on the direction it's moving, it sounds like there needs to be a condition for that, which I have these key codes pressed in, so it may need to be done inside of the if statements. Let me just draft something first. Transform dot translate. It doesn't look like I'm doing that right. Shouldn't be that difficult. Transform dot no. Transform move equals transform dot no. Yeah, I don't know what I'm doing. Let's go ahead and just check it out. Unit transform, not local scale. Okay, so let's do this then. Private float. Current location. Private float destination location. Why are those gray? Okay. You know, it could have been because I was typing it outside of something. Yeah, transform dot position equals shit, vector 3. Transform position equals vector 3 dot. Down. So if eh, up. Oh no, this isn't vector 3, this is vector 2. Because we're doing 2D. Vector 2 dot left. Vector 2 dot right. In that case, these might not be needed. No, I'll keep them. Because I'm probably going to have to set something up when it's going from its current location to its destination. It needs to move over time, delta time or something. Private bool is moving Does this do wow? Wow. Wow, game object dot transform dot position is greater than no. Because this can also be negatives and stuff. How do you do not equal? Wait, I think I have this. No, because current position would never be equal to destination position. It would have to be... Think, man. Well, game object that's transformed dot position. I don't know how to logic this. So if I just write something is less than destination location and greater than current location. Um, mm, I don't think I'm doing the right thing. Let's see here. Try the Google. Every object in a scene has a transform. It's used to store and manipulate the position, rotation, and scale of the object. Every transform can have a parent, which allows you to apply position to scale hierarchically. This hierarchy can be seen in the hierarchy pane. Right. So let's see. The properties of transform. It's not going to be local anything. Position. So current location equals transform dot position. Why, bro? That's it. I didn't want to do it, but I gotta do it. So let's see. Okay, so like it's saying, since the movement is going to be restricted to when it's not currently moving, all these if statements need to be wrapped in the condition of if it is not moving. So this calls, or this holds all of these, and actually I want to tap these once so I can put another bracket, no, wrong bracket here. There we go. So if not moving, and the reason that we do that is it's currently set to false. So meaning if is moving is true, meaning the opposite of what it's currently set to, then when one of these is pressed, you'll be able to perform the action. So now what it wants to do is it wants to create a coroutine. This is probably fair. So let's see. We'll put a pin in this. I need to come down here. I enumerator. We'll go with move and rotate like it says. Why do you hate this already? Top level statements must precede namespace and type declarations. Oh, I put it outside the class. So it needs to go before this. Let's see. While this is happening, is moving equals true. So vector 2 current location equals it's probably the wrong way to do that, but it's fine. That'll code pass return value. I want to figure out what the fuck this is. I enumerator. IEnumerable objects. The objects can be iterated over. Collections are the most obvious example of this. A list is an IEnumerable, an array as well. Hash set, dictionary, etc. All an IEnumerable has on its interface is a method getEnumerator. GetEnumerator returns an IEnumerator object. This is the object that actually does the iterating. For each loops are just syntax sugar around the move next method of the IEnumerator. The iterator function you write for the coroutine returns an IEnumerator to facilitate this move next, which is used by the coroutine to move through the coroutine to each yield statement. Okay, this seems like a very useful article. Okay. So, besides that, then, I guess let's just go ahead and finish this out. Start down. What is it? What is a vector then? Is it an int? Is it, does this work? Okay. I guess before I start making a fucking asshole out of myself, I better just fucking do what this thing is telling me to do. I don't get it. This is what I just did this. Private vector 2 movement direction. Equals vector 2 dot up equals vector 2 dot left equals vector 2 dot right. So now it should work. Current location plus movement direction, which is a vector, should set the vector as whatever direction key is pressed. Okay. So oops. Okay. Use WASD, or you can use the arrow keys. So let's see. This is saying here, it wants to do the movement based on time. So what it's saying is, it's creating a float called elapsed, setting it equal to 0. And then it's saying, while elapsed is less than move time, which I have called, oh, I don't have one, actually. Sometimes the predictive text is just so goated. I have the rotation speed and time, which probably is the same thing, huh? No worries. Not greater than time delta time, but while it's greater than translation time. So while the elapsed time is less than the translated time, we should still be moving the object. So transform dot position equals vector2 dot lerp which is going to be current location target location is elapsed time divided by translation time with the colon. Not there. So and then it wants us to set lapsed time to be additive with time. Enter turn. No. So this is our first thing, which is to move it. While it's moving, it's going to be set as is moving. I wonder if this works already, actually. Save. Let's just try it for giggles. Damn. It moves, but I can only move once. Okay, it moves, but it only moves one time. Oh, you know what? It needs to be set back to is moving false. I see. It wanted to do all of it at once, so that was a kind of a bad test. So with that first part set, that should be movement. Calculate the target rotation angle based on direction, huh? Ah. Okay, so what it was suggesting, um, I didn't really feel like was the most appropriate. So let's try this new one here. Yeah, this makes sense. So this makes more sense to me. So in the same way that we checked the current location and then made the target location just 90 degrees off of the current location, what we want to do now is to set the current angle, which we'll call current rotation, which is equal to transform dot, and this one is called Euler angles dot z. We want this to be the z z rotation because this is the only one that really needs to rotate in here. Because when we turn it like this, you know, actually, that just made me realize something. I need to set this sprite with a rotation point, but shoot, where is that done? On the item itself? Man, I would have swore. Sprite editor. Yeah, pivot point. No, I do want the pivot point to be the center. Do I need to hit apply? So now when I go to rotate this, yeah. Was it different when I was trying to rotate this? It is. Why? Player move point. Can I see this? What is this? Get rid of this. We're just gonna make this sprite the player, which means I also want to add the rigid body. Rigid body 2D. I want to make it kinematic. I want the kinematics to be able to collide with statics because I want to set the border as a static. The interpolation shouldn't matter, but we'll come back to it if it does. So with this set in here, now when I do the rotation, it is set on the pivot point. Okay. So with it set on that pivot point, let's come back here. Now it should rotate around it normally. Actually, let me double check one thing. If I set this to 90, how does it look with the grid? Okay. Here, let me do this. Lock, grid. If I set this to 180, it's fine. What's it like on 0? Okay, what about 270? Not 970. 270. I don't think it's perfectly in the position that I want it to be in. Unlock. This says pixels per unit is 128. What if I set it to 64? What happens? It becomes much larger. So if I set it to 128 pixels per unit, what? I think the question is, what is the most central location so that it'll always be in a similar position inside of the square when it's rotating? Because if this is dead center, that's fine. What if I just go ahead and 0, 0, 0? And then this actually does have to be minus 0.5. So if it's at 0, 0, 0, how's the grid? Well, this kind of answers the question, because if it's saying its center point, it's just inside of the triangle. So it's kind of funny that the ridges can be seen. I guess if it's made out of pixels, it's gonna happen, huh? Well, let's do this. Let me lock player again and pull up the grid so that when I go to move player, how about this? How about, actually, you know what? How about minus 0.5? 0.5. Where does that take it to with the grid? Okay, so if I rotate it 90, 180, you know, that looks better. 270. Yeah, they are kind of in the same relative position now. Okay, I think that's better. It seems like the half point is what kind of set it in its in the center of the square. Since the square is 1 unit big, it kind of set it in the center of there. Can I lock? Now that's interesting too. The scale. What if I scaled it up to better fit the square? Oops, oops, oops. Control Z. You were supposed to scale all of it. Okay. 1.2. 1.2. 1.2. Yeah, I didn't think it was gonna do anything there. 1.3. Let's just find out what this fits to. 1.25. So 1.25. And now what happens if I rotate them 90s? It is like a singular pixel off. So what happens if I do 5.1? Oh. Was it just that easy? 90. Maybe not. 0.515. Try the same thing. Oh, no, 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 no. No, 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 no. 0.5 is like perfect. Yeah. 0.5 is like perfect for the vertical. So let's try now. It just puts it outside. I think let's probably not get greedy. Let's just go with 1.2 on the scales and just leave it at the 0.5 since that was working. 0. I mean, I guess it doesn't need to be perfect in there too. It can be close. Plus it can be tweaked later. So let's leave it like this. I forget how I even got off on that tangent. But let's go back in here. So we're setting the angles. And we're going to do something similar. Break my leg in my chair. So the target angle. How the hell did I type that? So the target angle, yeah, the target angle equals the current rotation, not times time delta time. We want it to turn clockwise. So, oh, okay. It wants us to just do it based off some simple math. So it equals the current rotation, and since it's clockwise, minus 90f percent 360f, which I assume is the degrees. So it says it also wants to keep it between 360 so that it doesn't just spin forever and generate massive numbers. So target angle is greater than 0. It give us a bracket here that doesn't have one here. I see. Target angle plus equals 360f. Not that one. This one. So keep it simple like that, or what? Here? Oh. So now it's also going to be using the same elapsed time, which is good, keeps it simple, but we're going to be doing the same thing. Elapsed time is less than rotation time. And now this is the actual movement. So let's go ahead and set this up. So the float of the z rotation is equal to, now I don't know what math f is, it's just this collection of math functions, but lerp angle, and we're going to be saying current angle, current rotation to target rotation, and I blanked and called this what ChatGPT wanted to call it, but I wanted to do current rotation, target rotation, elapsed divided by rotation time. Is that what I have it called up here? Yes. Rotation time, semicolon. Transform dot Euler angles equals new vector 2 O O Z rotation semicolon. Should be 3, right? Alright, and now let's just finish this up. Elapsed plus equals to time delta time, yield return null, exit the while loop, and it wants to do it again. Transform dot Euler angles equals new vector 3 OO target. Oh, I understand. Target rotation. So this is just saying while it's moving, it needs to be moving towards it, and then where it should end is the target rotation. And finally, is moving equals false. So that's right, I gotta change these to rotation. Gotta change these to rotation. Okay, so should work. Now let me ask a question here. Oh, interesting. So, something that I didn't know that is very important here, the difference between vector 2 and vector 3. With a little bit of intuition, you might be able to figure out that the point of the vector is to specify x, y, and z, which is the vector 3, but there's also vector 2, which is only x and y. Now, I thought anytime it was in a 2D game, it would use just vector 2 as opposed to vector 3, but it seems like that's not the case, because apparently, when you use vector 2, you cannot assign transform.position or transform.rotation. You need the vector 3 in there. So, and you know, even though you only use x and y, it still tracks the z-axis for things. I see. And I guess whenever you move an object using scripting, Unity is expecting the full 3D vector. I see. And so this also does change things, because when you use vector2.up, it means something different than vector3.up. Because if you think about it in 2D space, vector2.up means one thing, you're moving upwards on the screen. But in 3D, based on the orientation, vector3.up could mean up on two different axes. So that's why vector 3, this has different parameters. And of course, when you're putting it in there, like vector 3 dot down, there's more, I'm pretty sure there's more options. So we can just check. Vector 2 dot, got down, left, 1, right, up, 0. But if we did vector 3 dot, yeah, you can see we have back, forward. You know, we have these different ones in here. This kind of just keeps it a little bit more intuitive. So let's make sure that we have the appropriate vector 3s in here where it asks us to then. So it says at the top, input direction, which I have as movement direction, is a vector 2. Inside of the key codes, it has vector 2s, which is for the dot up, down, left, right. Next, what it says is to put vector 2 direction in here, but I don't know what this does, and it also is confusing. So the other thing that's important to note, let's see. I don't know if what it's saying is by direction is saying, you know, so to substitute it with something. Let's see. Okay. It doesn't seem to specify in here, but with this having no errors, I'm just going to try to save it like this, and let's just give it a try and see how it moves. So it should always be rotating on 90-degree angles when it moves, and it does nothing with either set of keys. Bummer. Why? Because it doesn't have the script attached to it. Duh. So, we'll come back in here to scripts. We'll attach player movement. Let's set translation time to 0.2 because that was kind of quick before it, and since, just for consistency, let's also try 0.2 there. So, well, it does it. I think I was hoping it would rotate while it's moving instead of getting to its destination and then doing it. However, this is working. Cool. Okay. Let me ask it some questions real quick so I can clarify just a little bit of information. One is that I am a little bit unsure about what it meant by having the vector 2 inside of the move and rotate pair of parentheses right here. I'm going to ask it why, what it's supposed to do. So I see this line. What is the point of the part inside the parentheses? God knows I'm not going to be able to spell that right. I got it. I spelled it right. So it's a parameter list. It's a coroutine method, and it's a parameter. It's a value you pass when calling the method. It is needed because when the player presses a movement key, you need to tell the move and rotate coroutine which direction to move. So this calls move and rotate and passes in vector2.up, which is shorthand for 0, 1, telling it to move up 1 tile. Okay, so it basically I did the same thing with this. It was just trying to do it a different way. Oh, I see. So it kind of changes it a little bit where instead of 4 if statements, 1 for each of the directions, what was happening is it's doing the if statements. Well, sorry, I shouldn't say instead of 4 if statements. Basically, I'm specifying the direction and then using the coroutine with this as a variable set for it. What it's doing is using the 4 if statements to set the direction, and then it's passing the, instead of doing it like I do through a variable, no, hang on, how the fuck am I trying to say this? I don't know. I guess I still don't understand. This is working, and I guess it's supposed to do the same thing, but I don't understand how the script is doing it. So I'm going to ignore it. Well, let me see. Okay, okay, so I asked it what the difference is between my segment and what it calls it the parameterized version is. So, it's saying that as far as readability goes, the parameterized version is a little bit more concise and self-contained. It says that the parameterized version is more flexible for dynamic directions, but what the fuck do you need that for? You're pressing arrow keys, you're only going in 4 directions. Also, it isolates the direction exclusively to the coroutine as opposed to leaving it as a global variable. I see. Well, I see. I see what it's saying here. It's basically saying that it should be better to be isolated to the coroutine for the purpose of keeping it in there. Since it's a variable, it is vulnerable to... I mean, I understand that I have nothing in here to change it, but if something were to set movement direction to something else, it might fail. Yeah, we aren't doing queued movements or overlapping movements, so we don't need to worry about the potential for it to overwrite the variable. If you want to be able to reference the last direction from other parts of the script later for animations or particle effects. Okay. The parameterized version helps if you want clean, stateless coroutines, if you're avoiding a shared state to prevent bugs, or if you might want to expand into queued movement, AI, or recording macros later. No. So what we have is fine. It works. I don't feel like fucking with something that I don't fully understand. So we're just going to leave it that way. Okay. Yeah, it basically, it says it's fine. It's just like they have slightly different purposes. So, next question is, I tested this, and it is working, but not quite how I wanted it to. I actually wanted the rotation to occur during the translation and not each motion one after another. Yeah. Okay, so let's see. Okay, so it's trying to update the move and rotate coroutine. Ah, I see. So basically what's happening is instead of having two while loops, it's putting them together into one, which makes sense. That was kind of the idea that I had, but I wasn't sure about if it was going to work. So we have to do a few things. One, we need to take all of our prerequisites and put them above the while loop. Next, we don't need our second here, and we don't need I see. It also condenses them into one called move time, which I can get behind. If elapsed is better than move time. Move time. Sounds like Burger Time, that old game. Move time. And we don't need this anymore. Or this. So next we need to take this piece, put it in this while loop, space them, and remove this yield return. So, oh, you know what? We probably also don't want this elapse. We want this elapse. So let's see. Let me review. So move smoothly is the transform. The rotate smoothly is the rotation section. And then separately, we still also have the elapsed time and the yield return null. Then to snap to the final positions, we still have these items in here. Except it wants to add another liner to not just make sure it's snapped to the target rotation, but to snap to the targeted transformation. So let's also add that transform.position equals target location. So yeah, this makes sense. It took those two separate functions that while it was doing this and while it was doing this, or while it was doing this, then while it was doing this, it puts them into one thing. So just at the same time, it should move and rotate here. Everything here is still used. Let's add some notes here. Setting the motion flag to true, so no other inputs will impact movement. Setting some prerequisites for the coroutine to understand where the object is and should be. And keeping the rotation between 0 and 360 degrees. Space this out a little bit more just because I like it that way. Measuring time passing for the motion smoothness. This slides the object. This rotates the object. This tracks the passing time. I don't know what this does. Snapping the object to its final location and rotation setting. So up here, based on key input, the object will move in the respective direction. Okay, so I think we've got good notes in there. Let's go ahead and double check it. Make sure it works. Nice. Okay, so with good motion in here, next up is going to be collision, yeah? Okay. We'll go in here. Created a new player movement script so as to use in-engine physics for collision as opposed to in script. Yeah, and right now, even though I'm supposed to be saving the changes to the project so that my buddy can also work on them, I don't have the permission to do that right now, so I just have to accumulate all these notes that I've put in here, and I'll just drop it in one big update. That was a big accomplishment. I'm pretty proud of that. So let's take the time to reflect on this, because I can't rely on ChatGPT all the time. I need to understand what's going in here. One thing is, I want to understand the coroutines, because coroutines seem like a huge way to accomplish something. For that, what I've got in here is this article, which I'm actually going to save. Yeah, I'll save it under the Unity folder so I can just take a look at that later. I've got this article, which I'm probably going to review. It seems kind of expansive, so I'm going to take the time on my own to read that out. I'm not going to just spend a bunch of time reading on stream. That doesn't seem very content appropriate, so I'll do that later. Some things is just going to be practice. I did know these, but I guess I forgot them. Using these is going to be helpful. What are these called? Conditionals, I think. I don't know. And using these items here is going to help. I set some privately. These ones, they don't need to be seen. They don't need to be adjusted from in the editor, which is why I left them as private. This one can be, just to aid with that. So for example, if we come in here and go to this, we'll see that the player movement, see the move time is set to 1. If I set it to like 0.4, then try again, the movements are going to be a lot snappier. And like that's fair. So I mean, if I set it to 0.1, meow, meow. That's kind of goofy. Then again, it kind of feels good. It's a little too fast. What about 0.15? Meow, wow, 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 wow. Okay, I like that. I think I'm gonna set it that way. We'll set that to 0.15. Hit save. Next, collision. Okay, we want to not be able to go outside the bounds of the border there, that darker border. And in addition, we want to be able to drop obstacle squares into the map so that you can't collide with them. I mean, this is supposed to be a puzzle game after all. Let me go ahead and let him know. So, let's see. I think what we need to do is go back to watching those videos on the collision. See what we can pick up there. So look, I'm just saying, it offered. It said, "Do you need to do collision?" I'm just gonna take advantage of it because I don't think I really know where to start, other than keep watching some YouTube videos. So let's see. It wants us to add the tile map collider. Tile map collider 2D. It says that it wants to add sorry, I just had a lot of thinking. So okay, so we probably don't really... Okay, now we can leave these separated because we do still have to turn on and off collision for certain levels. Let's do another one in here. Another tile map. Oh shit. New tile map. We're gonna call this one obstacles. Now this one is going to be a layer that I'm not going to touch for right now, but the purpose of it is going to be to act differently than the border, but still have the same kind of collision. So let's go back to this collision here. It says it wants us also to use a composite collider 2D, which I have seen a couple of times. In the tile map collider 2D, it wants us to check composite operation. Now this one makes sense because we do want it to be... That was kind of an abrupt change, but scared me a little bit. This is going to work because we do want it to be a solid barrier, even though I don't think that it's going to matter much. Composite collider 2D. We do want the composite to be set to... It says in the tile map collector 2D check used by composite. I don't see that. Let's go ahead and close those. Let me go ahead and close the script as well. Wait a second. Oh, jeez, it's locked. Okay. Let me take a second here. Okay, so the border is fine. The player... is also fine. Let's go back to the border. Okay, no, I'll go back to the player. I don't want tile map collider on the player. We will leave rigid body 2D. We'll come back to that. So now, border. Now we'll do it. We'll leave the rigid body for a second. Oh boy, oh boy. So we'll put the tile map collider on the bottom. And now let's go ahead and add the composite collider 2D. So under the tile map collider, we want to put in... Yeah, it doesn't show that button here. Make sure the rigid body is set to static, which it is. Man, it gives so much. I hate to skip over it for one stop. Oh. In the inspector, add a tile map collider 2D. Add a composite collider 2D. Now, and only now, you'll see the Used by Composite checkbox appear in the Tile Map Collider 2D component. It's hidden until Unity sees a composite collider that exists on the same game object. One problem, it still ain't there, bitch. Girl, you lying? Bro, you son of a bitch. It's like, hey, you have to configure it right in order for the Used by Composite to appear. It's not there, man. Okay, add a composite collider 2D. Right there. Must be on the same game object. It's there. Add a rigid body 2D. It's right there. Set the body type to static. It's right there. Now revisit the tile map 2D collector. Oh, okay, I didn't know that. Except it's not there. Okay, okay, that makes more sense. It says remove and re-add the tile map editor. It says if the tile map editor was added before those, it could cause this. But it's still not there. What a son of a bitch, man. I asked it twice if it had changed names or something, and then I specifically mentioned the composite operation. It was like, "Oh, you're right. Yeah, it's that now." I'm gonna lose it. um Okay. So it says we're going to be using an option that isn't there. I think at this point, it's going to be better to just check out a web article. So let's do this. Unity. Tile map collider. Composite operation. Okay, so in our composite operations, we've got the options here. Indicates a composite operation that composes geometry using a Boolean or, Boolean and, Boolean not, or Boolean XOR. That kind of doesn't help, so let's check it out a little further. Merge. Where both regions of geometry are merged together. Where both regions of geometry overlap. A region of geometry where the overlaps are not included. Regions where geometry do not overlap. Okay, sounds like what we're going for is just merge. So let's set it that way. And we do see that it becomes one solid collider. as opposed to when it was set to none. See how there's all lines between them, or it just puts them there. What about these other ones? Do you see any visual difference? Doesn't look like it. Let's just leave it on merge. And I've got to use the bathroom again, so I will be right back. Alright, back at it. So, we've got our border tile map set up. Let's see what's next. Now we can finally go check this out. Add a collider to the player. Rigid 2D body, which we've got. Oh, it wants a collider. Yeah, this is tough. Let's go ahead and just add a box collider. Actually, I'm moving on to adding a collider to a player. But my player shape is a triangle. Can I make my own collider so there is not empty space in it? You can make your own collider. Use a polygon collider. Polygon collider. Unity will try to auto-generate the shape based on your sprite. Well, it looks like it did a bang-up job there. Yeah, it looks like it's practically perfect. Okay, works for me. You can create a collider with code? Wow, interesting. Okay. Actually, it does add a good point, and that's that should make sure the collider stays with it when it's moving. So let me pull the game out to the side and move it. Yeah, it seems to stay pretty glued to it. Well, shit, as long as we're here, let's just go test it. Ah, bummer. Okay, we'll get there, but it looks like that's working. So let's go back up to our steps and try this again. Okay, so on the player, we should have a kinematic body type. Simulated is yes. Gravity scale is 0, but I don't even see an option for that. And the collision detection should be continuous. It says it's optional, but... So, collision detection before moving. Since your player is moving one tile at a time via code, you don't want physics to stop the move. You want to check if it's going to hit something before moving. Here's how. Use a physics check before moving. Is obstacle at target position? I see. I see. Well, fuck it. Let's just do what it says. Back to the code then. Big shock. Okay. Use a physics check before moving. So. We need to do a couple things. One, we need to describe... Well, let me ask this. Can I have multiple tile maps put into the layer mask? Can I have multiple tile maps put into the layer mask variable? A layer mask isn't about tile maps directly, it's about unity layers. So if you have multiple tile maps, like one for walls and one for obstacles, you just need to make sure that each tile map game object is assigned to a layer, and then include those layers in your layer mask. Okay. Okay, I did confuse myself with that, so I'm going to put a pin in that one and come back to it. So for right now, oh right, I'm all the way up here, right? Okay, so we've created a public layer mask. Assign this in the inspector. What? Oh boy, what did I just do? Accidentally closed my tab. Just gonna go ahead and scroll back to where I was at. Yes, use a physics check before moving. Sheesh. So, now let's try to save the code so that when we come in here, what we should see is on the right, so this is on the player movement script. What we should see is the obstacle. Okay, let's do this. So the border is going to be on the layer called that's interesting. It's going to be on the layer called blocked. Done. Blocked. And the obstacles are also going to be on the blocked layer. So when we come back to the player, under the script, the obstacle layer is going to be called blocked. This should define it. Let's hit save, and we're going to go back to our script here. So with this defined in here now, when we update our movement logic, damn. I'm just gonna go ahead and kill the start method. Let's do this. So, our boolean, we've created a boolean here that is a bit more than just a one-liner. Is obstacle at. That's where it's gonna check. It's gonna check the obstacle layer at the target position. Except for target position. I'm pretty sure this is going to be target location. Because I'm pretty sure that is the same as this. Does this also mean that I should be defining these beforehand? We'll see. So we need to update our movement logic. In your update function, check just before calling the coroutine, do this check. Looks like we need to put this in right here. So for example, the target location equals transform position plus vector 3 movement direction. I think it's just like this. Okay. Can I do vector 2? Okay, so let me think here. What happens if I pull these out and put them here? Really doesn't like that. So, what's next? Me. In your update function, just before calling the coroutine, put this in. And when I do this, oh, you didn't tell me you wanted me to get rid of this, bro. Okay, let's try it. Just for the sake of it, I am gonna call this target position, not posture. Jesus. Position, target position. Position. Let's give this a try. Not working. Hmm. This is tough. I kind of think the issue is with this. So the target position is equal to transform position plus the vector 3 of the movement direction. The thing that worries me is this specifies movement direction. Maybe then this is that scenario where we want to use the nested one here. So let me do this. I'm going to get this back to where it was working like I wanted. This is fine. I'm going to save it like this. I'm going to try to create a new script and just paste what the fuck ChatGPT says. I see. So I think when I did it in mine, I put this at the top. No, this is different. No. Well, this is a bit different, but let's go ahead and just test it. Let's get our player. I'm going to turn this script off, and if I do that, I shouldn't be able to move, right? Correct. Okay, so I'm going to turn that script off, minimize it. I'm going to put this script on it. In this script, I want the obstacle layers to be the blocked ones. Border is listed as blocked. Background is default. Obstacles is listed as blocked. So the border has this rigid body 2D. Now it says, to use this script, it says on the player game object, need a collider component, like the polygon collider. Doesn't look like anything extra needs to be done to it. And it also needs the rigid body component, which is here, set to kinematic. And enable interpolate if smooth motion is desired, whatever. It also says for the environment setup, ensure each obstacle tile map has a tile map collider, 2D. It's set to merge. Ensure the composite collider 2D with composite operation set to union. I don't see that. I see the tile map collider has a composite operation. And there's no union. There's merge, intersect, difference, or flip. And a rigid body set to static. In the Unity Inspector, assign the desired layers to the obstacle layers variable by checking multiple boxes as needed. The implementation ensures the group movement through a flexible layer mask approach. Okay, let's see. Okay. Okay. Okay, my setup sounds correct. Fingers crossed. Let's see. Okay, movement still feels good. Ah! Why you do this to me? Collision Checklist 101. On the obstacle tile maps, the border is, in fact, an obstacle tile map. Tile map collider 2D is present. Composite operation is set to merge. Rigid body is attached and set to static. Composite collider 2D is present. The tile map object is assigned to the layer blocked, which is assigned in the script as the obstacle layer. On the player object, it has a polygon collider 2D that fits it pretty well. It's set to kinematic because we're moving by a script. It has a rigid body, yeah. It is not on the same layer as the obstacle. It's on a default layer, but let me just try another one. Let me just fucking no, I'm thinking of a different thing. I don't want to fucking change the I don't want to change the layer. Let me just tag this as player. Tag this as add tag obstacle. Save. Border. Obstacle. Obstacles. Obstacles. Player. Player default layer. Border. Static. We'll come back to that one. Player. Script uses physics 2D overlap circle or similar to check collisions. Layer mask is in script. On the player, it's set to block. Duration is there. The script is using the grip movement. Common gotchas and fixes. Obstacle layer is missing in the layer mask. Go to the script component of the inspector and check that your layer mask field includes the obstacle tile map layer. Okay. Yeah, go to the script component of the inspector and ensure that the layer mask field includes the obstacle. Yeah, it's there. Gotcha 2. Overlap circle radius is too small. Fix is to increase the radius slightly. Try 0.2f, 0.25f instead of 0.05f. For some reason it never occurred to me that there was a radius set for it. Maybe the radius is too small. Small radii can miss the colliders due to tiny gaps between physics layers or positioning float errors. So let's try 0.25. Save. Okay, let's see. Damn it, man. And it just keeps on rolling. What is it? What is it? Border. I can see collision. Okay. Motherfucker. That's what it is. It's not detecting the collision because they don't exist on the same plane. How would this ever collide with this? It's all the way down here. Holy shit. No! I was so confident. It still moves into them. Ah. Alright, let's try to fix this once and for all. And actually, it's about 5. I think what I'm gonna do is I'm gonna call it on the stream here. But besides that, I am going to keep checking on this. I'll probably get in a call with my friend who is also working on this with me, and we'll see what we can come up with together. And I'll check it out later. But yeah, I'm gonna go ahead and cut the stream for the day. If everybody's still there, just lurking, thanks for tuning in. But I'm gonna go ahead and nip this one today. Thanks.